All right. Hey guys. So today we're going to look at 3.3, which is all about proving lines are parallel. It's going to look very similar to the things that we've done before in this chapter, using all of our angle relationships and whatnot. It's just going to be kind of from the other side of things. Instead of saying that the lines are parallel and then talking about the angle relationships that exist, it's going to be if these angle relationships exist, then we can tell that the lines are parallel. So it's the same thing, just kind of in the reverse order. So go ahead, grab your notes, and we're going to flip to 3.3, day 1. Pull that up here. 3.3, day 1. The top should look like this. I'll zoom out slightly here so we can see it all. Okay. So in 3.2, we had things like the corresponding angles theorem and the alternate interior angles theorem and stuff like that. So today with 3.3, we have the converse of those theorems, which is basically like saying the same thing but in the other way around, in reverse. So instead of saying if the lines are parallel, then the angles are congruent, we're going to say if the angles are congruent, then the lines are parallel. So first we need our theorems. So let's start with corresponding. If corresponding angles are congruent, then the lines are parallel. So if corresponding angles are congruent, then the lines are parallel. A way that we could kind of shorten this a little bit, since writing this out every time is going to be a little bit tedious, you could say if you could abbreviate corresponding, use the angle symbol for angles, use the congruent symbol for congruent, and then use the parallel symbol for parallel. That's a lot shorter than this blue sentence here. So anyways, if you want to abbreviate things like that, you're more than welcome to do so when it comes time for homework and whatnot. All right, alternate interior angles is going to go very similarly. In fact, I'm going to abbreviate alternate interior to start with, since we've been abbreviating that all along. If alternate interior angles are congruent, because this was another one where the angles were congruent, then the lines are parallel. This one, same idea. If alternate interior angles congruent, then parallel. Same thing with alternate exterior. It's going to go the exact same way, because alternate exterior was another one where the angles were congruent to one another. So if alternate exterior angles are congruent, then the lines are parallel. All right, same thing. We can also abbreviate this. If alternate exterior angles congruent, then we have parallel lines. And then, of course, same thing for consecutive interior angles, converse, except remember, consecutive interiors were supplementary. They were not congruent. So if consecutive interior angles are supplementary, running out of room, supplementary, then the lines are parallel. Same conclusion. So same kind of thing, abbreviating here. If consecutive interior angles supplementary. I'm going to abbreviate that with just sup. Then we have parallel lines. Okay, so those are our theorems. Really what we want to be able to do with these is take and notice the angle relationships in the picture and be able to figure out if the lines are parallel, and if so, which of these angle relationships is the reason that the lines are parallel. That's really what we want to be able to do here. So looking down at some of these examples, the first one, we want to, for these first four, find the value of x that makes m parallel to n. So here's m and n, and this is going to look just like the problems that we were doing in 3.2, where we were told that the lines are parallel. This time, we're just finding a value of x and kind of rephrasing the question and saying that this value of x makes the lines parallel. So same exact kind of problem. In this case, looking at the first one, we've got this angle right here and this angle right here. We know this one is 130. We know this one is 200 minus 2x. So let's notice the angle relationship here, because it does say to explain our reasoning. These are alternate exterior angles. So if that's the case, then we know that they must be equal to one another in order for the lines to be parallel. So I'm going to set up an equation. 200 minus 2x equals 130. Then I'm going to solve this. I'm going to subtract 200 from both sides. We get negative 2x equals negative 70. Then we divide by negative 2 on both sides to get x equals positive 35. So that will be our answer for number 1, and we're all good. We can say x is equal to 35, and for our reasoning, we can just state the angle relationship that goes with it. These were alternate exteriors. All right. So hopefully not so bad so far. Moving on to the next one. We've got 2/3 x equals 48 degrees. And we know, or sorry, 2/3 x and we have 48 degrees. They are going to be equal. And that's because in this case, this angle and this angle are alternate interiors. They're on opposite sides of the transversal. They're inside our set of two lines here. Alternate interior. So I'm going to write that down real quick. Alternate interior angles, so that we know. And since they're alternate interiors, we need them to be congruent to one another. So I'm going to go 2/3 x equals 48. Now to get rid of that fraction, you can just flip and multiply here on both sides. So I'm going to multiply by 3/2 times 3/2. That cancels the fraction. And then we go 48 times 3 divided by 2. We get x equals 72. If you need to use a calculator to do that, you're more than welcome to do so. And we have alternate interior angles, and because of that, x equals 72. Okay. We got two more here. For this next one, I would encourage you to pause the video real quick and give this one a try on your own. See if you can pick out the angle relationship, and then see if you can figure out what x is supposed to be. So pause the video real quick and do that. And then once you're back, I'll go through it as well. Okay. So hopefully you paused it and worked it out on your own. If you did not, or if you're not sure of your answer, we're going to go through it here anyways. So we've got two angles going on here. These are corresponding angles. Remember, corresponding is when they're in the same position within their group of four angles. So this is like if you think of this as a group of four, this is kind of the bottom right corner. This group of four, this is the bottom right corner. So they are corresponding. And so then that means we need them to be congruent as well. So we're going to go 95 equals 8x plus 55 and solve that equation for x. So minus 55 on both sides. If you went 8x plus 55 equals 95, you're going to get the same answer. So it's okay if you set up your equation the other way around. So we should get 40 here equals 8x. Divide by 8 on both sides. We should get that x is 5. All right. And then the last one, if you want to do the same thing, where you pause the video real quick, give it a try, you can do that. Otherwise, I'm just going to also keep going and show this one real quick. So on this one, we notice, hopefully, that our angle relationship is that of consecutive interior angles. They're on the same side of the transversal and they're inside the parallel lines. So at the top, I might write consecutive interior, because that's going to be my reasoning. And then that means that these two have to add to 180. So if this is 88 and these two add to 180, we can just go 180 minus 88. Which should give us 92. So then I know that this angle has to equal 92. So now I can just go 1/3 x equals 92 and solve it the same way that we solved this one with the fraction. I can multiply by 3/1 on both sides so that my fraction cancels away. 92 times 3/1 is 276. So we're good to go there. All right. So that's one style of problem that we'll be asked to do. And you guys have seen these ones before. You guys can do these. It's the same kind of thing, just phrased differently. The next style of problem that we're going to see is down below. It's going to ask you something like, is there enough information in the diagram to conclude that M is parallel to N? If so, state the theorem you would use to show it. So what I would do for these is look for an angle relationship. It's going to show different angles in the picture that are congruent to one another. If you can name an angle relationship that goes with it, like corresponding or alternate interior, then that's what we want to use to show that the lines are parallel to each other. If you can't name an angle relationship that shows parallel lines, like if you can't name one of our 4 that we just listed up top, then our answer would be no. There's not enough information. So let's give this a try. For number 5 here, we've got this angle and this angle right here. We know those are congruent. So thinking about my angle relationships, this one's a bottom right corner for this group. This one's a bottom right corner for this group. They're in the same position. These are corresponding angles. And if corresponding angles are congruent, like we have up top here, if corresponding angles are congruent, then the lines are parallel. So we're good to go. So we can say, yes, there is enough information. That's the first part of our answer. And then the theorem that we used is corresponding angles converse. Okay. The next one, number 6, we see these nice vertical angles here. Unfortunately, we don't have any of our 4 angle relationship names from up above. We don't have anything corresponding or alternate or consecutive or anything like that. We just have vertical angles here. So this is one of those cases where no, not enough information. And then we're done, because vertical angles is not enough to tell that lines are parallel. Actually, the same thing goes for number 7 here. We've got a pair of vertical angles, which is great, but it doesn't tell me anything else about other angles in this picture. So unfortunately, this one is also no, not enough information. But let's take a look at number 8. Hopefully that one will give us what we need. Number 8, we're looking at these 2 angles, which means that this line right here is just a distraction. So we can kind of cross that out. That one's not helpful to us. Looking at these 2 angles, thinking about our angle relationships, if this is my transversal These are on opposite sides of the transversal, so they are alternate. And they're outside lines M and N. So those are alternate exterior angles. And if we look at our alternate exterior angles converse theorem here, if alternate exterior angles are congruent, then the lines are parallel. That's exactly what we have. We have congruent alternate exteriors. So we would say yes, alternate exterior angles converse is the theorem that we used. All right. So as long as you can pick out one of our 4 angle relationships, you can say yes because of that angle relationship. If not, then we say no, not enough information. Okay. Once you have that, go ahead and turn the page. And we are getting kind of into the homework territory here, but I'm going to look at 1 or 2 of these and talk through them with you guys. So first of all, I know some of these aren't super clear. So this is supposed to be line L. This is supposed to be line M. This is N. And this is P. So just go over those real quick. Make sure that you've got the right thing going there. And then it tells you some angles that are equal to each other down here or that add to 180 or something like that. And we want to know which 2 lines are parallel, if that's true. And then what's the reason? So our reasons would be things like alternate interior, alternate exterior, consecutive interior, or corresponding. Those would all be good reasons to use, depending on the angle relationship between these 2. So for my first one, I'm told that angle 1 is equal to measure of angle 3. So here's angle 1, here's angle 3. I know that these 2 are equal to each other. All right, so if that's the case, this is my transversal. And if this is my transversal, the 2 lines that it crosses are L and M. So for my answer here, because 1 is congruent to 3, I can say that line L is parallel to line M. And then my reason would be the angle relationship between these 2. 1 is the top left corner angle in this group. 3 is the top left corner in this group. Those are corresponding angles. So I would say for my reason, corresponding angles converse, just like we did on the ones on the previous page. So number 2 is going to be the same idea, except you're labeling angle 4 and angle 15 and trying to say which lines are parallel, and then what's the reason, what's the angle relationship. Same thing for number 3, 10 and 6 add to 180. Which lines are parallel, what's the reason? Same thing with number 4. If 14 and 11 are equal, which lines are parallel, what's the reason? So make sure you label in your picture because that's going to help you figure these out. So that's the rest of these 2, 3, 4, and 5. That's part of your homework assignment. So if you need to circle them, so you remember, go ahead and do that. Then go ahead and turn the page. All right, and then 1 through 6 here ask, is there enough information to prove that lines P and Q are parallel? If so, state the postulate or the theorem you would use. So these are just like examples, examples 5 through 8. So if you need to, go back and look at examples 5 through 8 and see if that can help you with any of these. You need to say yes or no if there's enough information. And then if there is enough information, say which angle relationship tells you that there's enough information. And then lastly, 7 through 12 down here. These ones you're solving for x that makes m parallel to n. These are just like examples 1 through 4. So if you need to, go back to 1 through 4 examples and take a look at what you did there and see if you can figure out how to solve for x based off of those if you need to. Remember, we're looking for angle relationships, and things are either going to be equal or they're going to add to 180. Okay, that's all for this video. Your homework again is 2 through 5 on the previous page and then 1 through 12 on this page. Good luck. Have fun. If you have questions, feel free to ask. Have a good one.